Hi everyone, Salawi here, and I'm here to talk about the Activiti Cloud Blueprint application that we are building. It's all about trending topic campaigns and how to analyze social media feeds in order to detect different situations and create marketing campaigns to engage people. So my name is Mauricio Salatino, and I'm currently in charge of leading the Activiti and Activiti Cloud open source initiatives. We are focused in providing a set of cloud-native building blocks to provide business automation in cloud environments. We are collaborating and integrated with a bunch of different frameworks and a set of technologies that allows us to not reinvent all the things that are required to provide a set of functionalities in cloud providers. I totally recommend to take a look at the Activiti Cloud overview video that I posted, and you should be able to find the link in the comments. This video, it's all about why we are building BluePrint applications and what are the main points that we are trying to make here. We wanted to make sure that we go through the same pain of someone trying to implement solutions with our building blocks. So we are moving forward like this idea of having a continuous deployment scenario where we can test each of our early access releases and our major releases as well. So we will go through the same set of practices that you will end up doing in a real-life project. As I mentioned before, we are going to build several blueprints covering different scenarios. We wanted to make sure that we cover like different patterns that are kind of like recurring in different industries. And in order to do that, we started with this one, which is a very, very simple scenario, but it's covering like a quite wide range of situations that we wanted to make sure that our platform will support from day one. So in this case, we are sitting in the feed of a worldwide marketing company. They wanted to promote products all around the world, and in order to do that, they are monitoring different trending topics in social media. They can, pick Twitter, pick Instagram, pick Facebook, and then analyze what's happening. And based on that, they wanted to create marketing campaigns to promote their products associated with those trending topics. In order to do that, they will need to deal with different departments promoting different products in different countries. And they are all independent, and they all have different requirements from the point of view of scalability. Right? It really depends on how many people you get engaged, and in order to calculate the amount of resources. And all this needs to be flexible enough to scale and fast enough so you can react on trending topics that are happening right now. Campaigns are going to be created for different topics in different languages, in different countries, and they should all share the same infrastructure to run this. So we as a company can monitor what's going on at all times. As I mentioned before, each campaign will be autonomous, and it will be driven by the requirements of each department and different products. And again, campaigns will be created based on the assumption that they will consume data from social media feeds, and then trying to measure some kind of engagement with the users that are reacting to those campaigns. We want to make sure that we can react fast to what's going on out there. Trending topics cannot be, you can just not know when a trending topic will start going on. In order to react to that, you should be able to create these campaigns quite fast and deploy them and just get them up and running quite fast. So we are providing the tools to enable you to fulfill these scenarios, and during this video I will show you how these campaigns run, what's the required infrastructure, and what are the shared pieces that each of these departments will share when they are creating a new campaign. So first of all, we need to understand the what. What is the main objective for each campaign that we create? And that's defined with behavior, and the behavior is going to be encoded in business processes. In this case, we have two different business processes. One is what to do with the trending topic, meaning that as soon as we recognize there is a tweet or an item for a social feed that contains a keyword or a phrase or something that's related to our campaign, how do we process that? How do we clean up that content? How do we match and analyze and do some kind of sentiment analysis about if this is a positive comment or is this a negative one, and then how we rank that user and the engagement of that user with that campaign. And then if we have engaged users, we will probably want to reward users. Like as soon as we created the campaign, we can also define another business process that define the behavior on how to reward users after a certain period of time of engagement. Now the how. How are we going to implement this in order to get this scalability and the flexibility to create multiple campaigns that consumes the same kind of content? So in order to describe this, we need to remind the concepts review that we reviewed in the previous video about the cloud native architecture in Activity Cloud. Each of these campaigns is going to be a runtime bundle, and this runtime bundle will contain this definition of the behavior that we want to execute in each campaign, meaning how do we process each tweet in this case, and how do we reward users engaged with this campaign. These campaigns are going to interact with external and third-party services in order to do different things. For example, in order to do sentiment analysis, we are going to interact with a service. In order to rank users and engagements, we are going to interact with another service. And in order to reward and to calculate the rewards based on the top X ranked users for that campaign, we are going to interact with another service. It's important to understand that each campaign is going to create a new process instance based on each of the items that are being consumed via a connector that is going to pick up things from the Twitter global timeline, and it's going to send messages into campaigns. The mechanism here is quite simple. It will send messages to the pool of campaigns, and each campaign that is interested in that content is going to pick it up and process it. So we can have the same tweet going through multiple campaigns if that's needed, or we can just encode these messages in a different way and configure these campaigns differently if we don't want to do that. Interesting enough, all these campaigns are isolated units, meaning that they will be executed in isolation, and that will enable us to scale them independently in the same way that the interaction with the third-party systems. Notice also that because we are going to consume the Twitter global timeline, the amount of process instances that are going to be created and to be analyzed per each campaigns are quite a lot. And if we start adding more social feeds like Instagram and Facebook, and we want to start correlating information from these social feeds, then the amount of processing required is quite huge. But this architecture is created in order to support these kind of scenarios, because it will automatically create replicas as soon as they are needed, and we can dynamically add new campaigns without affecting the currently running campaigns. So now we are going to switch to the demo side. And you can find all this demo inside this GitHub repository, BluePrint trending topic campaigns, and you can execute it in your own environment. I will be executing this in Minikube, but you can deploy this in AWS running Kubernetes or any other cloud provider that provides Kubernetes support. As I mentioned before, you can take a look at the GitHub repository containing the BluePrint example. In this case, we have one repository per scenario. In this case, this is the trending topic campaigns scenario. And what you're going to find here is a runtime bundle, which represents the campaign. You can create as many runtime bundles as you want, as many campaigns as you want for different trending topics. And then you will have a set of Activity Cloud connectors, the ones that interact with external systems. So we have one connector for Twitter, and this will ask you for the Twitter credentials in order to connect to the global Twitter timeline. But in order to test and to make sure that all the services are working correctly, we created this dummy Twitter feed that it basically allows you to start and stop the feed whenever you want, and also for unit testing you can send one tweet at a time and see how it works. It also allows us to change the rate and the speed in which the tweets are being sent, and these tweets can belong to different campaigns, so you can use it to test different scenarios. We have a sentiment analysis using a natural language processing library here, so we route the tweets content through this service in order to get like a positive or negative sentiment around it, and based on that we rank the user's engagement with this campaign. We also have a reward mechanisms that basically create different rewards and send tweets to the winners using the Twitter connector. As you can see here, you will find two different ways of deploying and running this example. You will have the Docker Compose way, which basically uses Docker Compose in order to bootstrap different services, the different pieces. And you will also find the Kubernetes approach, which is the one that is always recommended, because this is way much more closely related to what the production environment will look like. There is also another way of running this, is using just the Spring Boot apps, and you can use the Maven plugins or just compiling the applications and then executing the applications. You will end up with these demos where you have tons of terminals being opened, and in order to see how they work, you just need to jump from terminal to terminal. We are planning to build a UI for these, but for now I will just show how this works inside Kubernetes, because we believe that that's our main target deployment infrastructure, and we want to make sure that we build cloud-native applications that works in that environment. So feel free to take a look at the Kubernetes descriptors. You will see how they are configured and how the services are being exposed. Okay, so I've just cloned the repository and now I have the projects in here locally. In order to run these projects, you need to have a Kubernetes installation available so you can deploy to it. That Kubernetes installation can be local into your machine if you want to use Minikube for testing purposes and for development purposes. If you want like an environment where it looks more closely related to a production environment, you can install Kubernetes in AWS using kops or any of these tools, or you can use Rancher to provision Kubernetes clusters. So the first things that you should do here is have Minikube up and running. I have it running here, so I have the Minikube, the Kubernetes dashboard, showing me all the services and all the deployments that I have. The next step, again, as I mentioned before, we have several projects. We have several projects, and these projects are needed. We need to compile them and create Docker images from them. So in order to do that, we use the Fabricate Maven Docker plugin that allows us to convert from a Spring Boot app into a Docker image. And in order to make those Docker images available for the Minikube environment, we need to run this command, which basically is going to configure our Docker daemon to point to the Minikube Docker daemon. So it will have these images, Docker images available when we compile them. If you execute npm clean install, you will get all these Docker images for all these projects, and as soon as you get that, you can start deploying those Docker images inside Kubernetes. Kubernetes will take the descriptors that we are providing, you can change them to modify your needs, and it will start provision those instances for those deployments and for those services. As soon as the build finished, we have all the Docker images from our projects ready to go, and they have been published into the Minikube Docker registry as well, so Kubernetes can pick these images and start creating new instances. So as I mentioned before, we are using Kubernetes because of its simplicity and its exactly similarity with production environments. So we wanted to make sure that you execute a set of commands here to deploy these things in different layers. So I will start by showing you how to deploy the basic infrastructure, which is basically in this case RabbitMQ. RabbitMQ is going to be used to communicate different connectors and with the campaigns and with the other services. So for example, if you do kubectl create -f basic infrastructure, you will see that there will be a new deployment and a new service for RabbitMQ. So as you refresh the screen, you will see that now RabbitMQ has been provisioned and you can start using it. Then the next thing that we can do is we can deploy our campaign, right? So we have an example campaign created that is going to pick tweets related with Activiti, and it's going to create a marketing campaign around Activiti, and it will give rewards to users related with this campaign. So if we want to do that, we will do something similar, kubectl create -f campaign runtime bundle for the Activiti campaign, right? And this is, if you take a look at here at the detail, it's deploying a new runtime bundle and also Postgres, right? So this campaign by itself, it's not going to do anything. It's going to just be listening to incoming messages from different feeds. And until now, we don't have any feed available, right? In order to do that, we need to start what we call connectors. And these connectors are the ones that are in charge of connecting the runtime bundle, the domain-specific bit, with third-party systems in a bidirectional way, right? So it's going to pick up information from outside and inject that into the campaign, or it's going to send information out from the campaign to third-party dependencies. In order to start these services, we just need to do kubectl create connectors, right? And this is going to create all the services for these connectors to work. Notice, it's really important to notice that I could have started all these things in completely different order, and each cloud native building block is going to wait for all the services that it needs in order to run. So as soon as these services are up and running, they're going to start providing the information required to work to all the other pieces. If you refresh the screen, you should be able to see that there are several deployments now. Kubernetes is provisioning these services, and these Docker images are being created and instantiated by Kubernetes. Each of these Docker images are starting at the same time, so for a local environment this is quite heavy, but for a cloud provider this is quite a normal thing to do. We were going to, as soon as these services are started, we are going to use Postman in order to send some REST requests to the endpoints. So for example, the first thing that we can do is we can check if the dummy Twitter feed is up and running. The service is not running yet, so as soon as that gets started, we can do that. And then what we can do is we can check up the rankings for the different campaigns. As soon as we have all the pods deployed and started, here we will have a green mark saying that everything is up and running. Remember that these are Spring Boot applications, so that means that each of those has like the health and the health actuator to understand if it's up or not. So we can create different probes in order to understand, if the service is up and running or not, and if they are responding requests or not. So if you take a look at you can go into any of these and take a look at the logs and understand what's going on inside the application. The first thing that we can do is that we have the Twitter dummy feed created, but it's not started just yet because we didn't want to start sending tweets right away. We wanted to make sure that we can control that. So we can get the status of the feed, and in this case is stopped. So we can start the feed again, and as soon as we do this, there will be tweets being sent against the campaigns. Depending on how many do we have, each campaign will pick this tweet and will analyze it. It will drop it if it's not related with the campaign, or it will process it if it does. We can take a look at that, and we can take a look that the connector is actually tweeting things. So we will go to the pod, we will go to the connector Twitter pod, and we can take a look at the logs. And you will see that this one is sending a lot of tweets. Right, and some of them they are related with activities, some of them they are not. So the ones that are not are going to be discarded. You can take a look at the campaign as well to see what's the campaign output in the pods. So you can take a look at the campaign, you can see the logs, and you will see that it's matching and not matching tweets depending on what's going on. Remember that we will create a new process instance per tweet in order to process it. This means that the campaign will do a lot of heavy work, and based on the load of the campaign, we can create new replicas for this pod. So the infrastructure supports creating as many replicas as we want for any of these services, meaning that if this campaign is under heavy load because there are a lot of tweets related with that campaign, new instances of this pod will be created and a load balancer will be put in front in order to redirect requests depending on how it's appropriate. Now that the feed is coming into the campaigns are processing these tweets and they are ranking users. So the next thing that we can do is we can go to Postman to check the ranking service to see if there are ranked users with the campaign that we started, which is the activity campaign. And in order to do that, we can again go back to Postman and execute the request on that service and to see that we have some ranked users here. These ranked users are going to be used by the other process definition, which is going to be triggered every minute in order to reward the top 3 users for each campaign. This works by default, and you can change all of these inside the campaign configuration, and you can provide your own domain-specific campaign requirements inside the campaign runtime bundle. In the next video, I will be showing you a little bit about how to create these runtime bundles from scratch, so you can understand a little bit more about how a campaign is created and how you can create your own domain-specific constructs inside the runtime bundle. In order to finish this presentation, I wanted to show you a little bit about what's next inside this blueprint. Inside this blueprint, we can include visibility and traceability using zipking. This is already supported by Activity Cloud, and all the dependencies are in there, meaning that we can start zipking inside Kubernetes and we can start looking at the traces between each of the service calls. This will give you a quick representation of what's going on when you receive a tweet, how many services are impacted, and if something goes wrong, you can quickly find out what's the main problem or where is the latency. Distributed logging, we can use also the Elk stack, which is Elasticsearch, Logstash, and Kibana, in order to define different KPIs and understand again what's going on and how the services are interacting, and gaining some visibility and being able to search on different traces in order to understand what's going on with a certain instance in this case. Using the service registry as well, that's another thing that we are going to include in this blueprint because that's a big part of our infrastructure. So knowing how many campaigns do we have, how many connectors do we have, and how they are working all together, it's really important. Having a service registry where you can just hit and get the reference of where that service is running, it's really important. remember that you are running in a distributed infrastructure, so things can go down, and the main purpose of the service registry is that to keep track of where things are running, so you can find the reference and just execute requests against that. The configuration server is another important building block that it's already included in Activity Cloud, but the example doesn't have any configuration, that it's being handled in a distributed fashion. And by having this, we have a centralized point where we can just change and update configurations while the services are running without restarting any of those. And again, just adding multiple feeds from different sources so we can test how the infrastructure scale up and create new replicas of the services and new replicas of the connectors as needed. So there are a lot of things that we can do here, and there are a lot of things that we wanted to do, but it's really important for us if you give us some feedback about what's the most important thing that you would like to see in this kind of demos, and we will make sure that we include that in the roadmap. Before I finish this video, I just wanted to give you a quick set of links, and you can take a look at these resources. I totally recommend the Git book and the previous video about the Activity Cloud overview, so you can understand a little bit about the fundamentals of this new infrastructure and how these applications are running. Thank you very much for watching, and please check the resources that I gave you there, and I will add all those links in the comments as well. Bye!